In today's lesson, we are going to practice what we learned in our previous module. So let's get started. This module is just going to be our practice session. That's going to take about our full 30-minute allotment for me to go over the problem, go over the answer, and to give you some time to actually try to code it yourself. So let's not waste any time. Okay, so this is one problem, but since we're doing subqueries and CTEs, it's actually like 3 mini problems. So let's go over this part by part. For part 1, I would like you to create generation buckets based on the birth year column in our city bike data. And I have the generation buckets listed right here. And this is something I just Googled to see what years would classify as what generations. That's where these numbers came from. In this same part, convert trip distance from seconds into hours. So make sure you divide by 120, not 60. Convert your latitude and longitude from your start and stop stations into geopoints. Filter out any bad lat/lon values, so that's when it's equal to 0 or if it's missing. And then filter to only the year 2014. So this is going to be CTE 1 or your innermost subquery. Then you're going to build off of this for part 2. So you're going to use what you did in part 1. Then you're going to calculate trip distance in meters and miles. So just as a reminder, when you use the calculate distance in Google BigQuery, the output is meters. So you need to convert that into miles. And then calculate your miles per hour. So we had the trip distance that we converted into hours in part 1. You're going to use that in part 2 to get miles per hour. And then in our final part, this is when we're going to aggregate. I would like you to find the following by generational type: total number of riders, average ride time, average trip distance, average miles per hour. If you get through this really quickly and you're feeling really audacious, however you did it, if you did CTE, flip it to subquery. And if you start with subquery, flip it to CTE. And when you go through it, it should be the same, the output. So pause the video, take a few minutes, and when you're ready, we'll come back and take a look. I hope that wasn't too difficult, but if it was, no worries. We'll go through it here together in the Google BigQuery interface. Okay, so here we have our instructions. I have them just written out in our Google BigQuery. The first thing I'm going to do is, because this is a lot of text, I'm just going to go ahead and do a little copy paste here. And I'm going to open up a new window. So basically what I'm doing is I'm breaking this up into my test window, and then I also have my, once I get everything tested out and I feel really good about the query, then I'll go back and paste it into the main one. But this is just to help me stay organized and keep it all in one space. Okay, so first things first, we know what are our keywords. We're going to need select, we're going to need from, we're filtering, we're going to need where. Okay, we don't need anything else looking at this. From, easy enough. We have our table. Select, I want birth year, and then I need trip time, and then I need the lat and lon. I think that's it. Okay, so we're going to start with select birth year. Then we want, I think it's start, station, latitude, start, station, longitude, end station, latitude, end station, longitude. Okay, then let's see. I'm also going to want to get the year. So we're going to do extract year from, I think it's start time. I can't remember that one. Start time, yep. And just as a reminder, I did the control click and then this opened up this table here. Okay, let's see, what else do I want? I think that's it. I think we're in good shape. Oh, I forgot trip time. Okay. Derp. And then we're going to do a safe divide trip duration. We're going to divide that by 120 as trip time hours. Okay. And for the where, let's see, we want to filter out bad lat long values and filter to only the year 2014. Okay, so let's just do where we already have our year here. Extract year. Paste it here. Okay, so where this year what equals 2014. Okay, so that's the easy one. The hard one is going to be filtering out these bad lat long values. And let's see. Start station latitude is not null. And start station latitude is not equal to 0. And the not equal is the little greater than or equal signs. Why does that make not equal? Don't know. Somebody decided to pick that a long time ago, and that's what it is. Okay, and then we're going to repeat this for end station. I'm sorry, we're going to repeat this for start station longitude. Now, the reality is that if your start station latitude and longitude is okay, then I would assume that your end station longitude and latitude would be okay, but we want to be really careful in data analytics. So if you make an assumption like that, you're going to have to verify it. If you don't want to verify it, then you're going to have to include it in the where statements. So now we need to repeat all of this, but for end station. Okay, and we're going to flip all of these starts to end. And there's a shortcut I was about to show you on Windows, but I upgraded to this Mac and I'm still figuring out all the keys, so to be coming. All right, let's see. Unrecognized name, start station latitude. Uh-oh. Well, that's because I spelled it wrong. Okay. And since I copied paste, same thing here. All right, so I have my green check mark, says that I can go. Let's just take a look and see everything we've done. So we haven't actually done the big kahuna, which is create the buckets. Right now what I'm doing is I'm just pulling in the basics, the easy things that I know, make sure it looks good, and then we'll move from there. Okay, so I should get year, trip time in hours, birth year, start station, longitude, latitude, end station, longitude, latitude, and then I filtered for 2014 and then scrubbed out any bad latitude, longitude. So Control Enter or Command Enter if you are like me in a Mac. We're going to run that, see what it looks like. Okay, hours look normal. We have our year, birth year, and longitude, latitudes look same. And you're going to see a lot of repeats. You might say, oh, is that wrong? No, it's just because there's only so many stations that people can go to. So you're going to have a lot of repeats. Okay. Now that we feel good about this, let's go ahead and convert our longitude, latitude points into the geo points. So that's geog underscore point. Forgive me, st geog point. Okay, so this takes in the longitude first, then the latitude. So start station longitude, comma, start station latitude as start point. Then I'm going to get rid of these. Oop. Start station. Wow, I can't spell today, guys. Okay, I'm going to get rid of these because I don't need these anymore. I only wanted them for the point. I'm going to do the same thing again. And this is how I would always code, is if I felt least comfortable creating the buckets, I'm going to start with what I do know. And that way I'm feeling accomplished and I'm also chipping away at the problem. Okay, so now I feel good about this. Okay, let's run this, make sure it looks good. Now you might wonder why I do a little piece and then I run it. Doesn't that waste a lot of data? Yes, it does. But luckily the queries we're doing are relatively small. And when you're learning, it's really important that you do piece by piece, because if you do a whole big query, it's really hard to debug. So we just want to make sure that as we go, everything's looking good. Okay, so we have the year, the trip time, the birth year, and now we can see that these are points, start and end. So that's great for when we need to calculate distance. Okay, so the last thing we need to do is use our birth year to create these buckets. So we're going to say case when birth year between 1928 and 1945 and silent. And I'm going to check these birth years because I'm worried that it is a string and I'm putting it as a integer. Nope, it's an integer. Okay, great. Okay, so when birth years between 1928, 1945, then silent. Next case, when birth year between 1946 and 1964. Something BigQuery does is it like autofills for you, and it always, for me, autofills the wrong thing. Then boomer. When birth year between 1965 and 1980. Then Gen X, when birth year between 1981 and 1996. Then millennial. And when your birth year comes up, go ahead and just like this video. That would be a big help to me. Okay, between 1997 and 2010, then Gen Z. Now you might be tempted to put, if it's not any of these criteria, put an else Gen Y. Is that it? Gen Alpha. But what happens if we have a missing value? What's going to happen to him? Well, if I put else, put him in the Gen Alpha bucket, then any missings will get put into them. So we don't want to do that. So we want to say when birth year greater or equal to 2011, then Gen Alpha. And we should have 0 for Gen Alpha because we're filtering our data to 2014. So the only people who would be Gen Alpha at this time would be 3-year-olds. So hopefully we don't have any, but who knows? Okay, so now that we have our inclusive buckets all the way from 1928 to 2011, we're going to put in an else missing birth year. And now we're going to put end as, we'll call this generation bucket. Okay. Oh no. Okay, so I forgot to put in the underscore. It's okay, easy fix. And then we'll just put a space in here. Okay, so I got the green check. Let's run this, take a look. We have the birth year and then we have the generation bucket, and it's good to have the birth year while we're looking at the buckets just to make sure that they look good. And from what I can see, everything is looking pretty good, so I feel confident. So my next thing that I'm going to do with this query is I'm going to just get rid of birth year. You might say, why? It's not super important, but in general, it's best practice where if you don't need a column, don't pull it because that does require more data. So in terms of being a good analyst, you don't want to be pulling too many columns. Okay, so the next thing is let's go ahead and collapse some of these things so it's not so big. Okay, so this is part one. And we're going to start with this example doing it as subquery, and then we'll do CTE because I think last time I did the other way. Okay, so this is my final. not my test. So I'm going to just paste that in there and just collapse these columns again. Okay. So next part is this. So I'm just going to copy this over, flip over to, this is my test window. And you don't have to be doing it this way. This is just how I like to do it. Okay. So we have our data here. And I want to create miles per hour. Okay, so to create miles per hour, I already have hours. I need to get to miles. I need to get to miles. So what I'm going to do is I'm going to use my start point and my end point. I'm going to find the distance between that, which is in meters, and then I'm going to convert it into miles. Then once I do that, I'll just divide my miles over my hours, miles per hour. Okay. So if we're doing this as a subquery, my first thing is I'm going to tab in one time with my note, part 1. And then I'm going to create the shell of my subquery. So we're going to do the same thing before. Select from, and from, as we know, is going to be part 1. So I just do open parentheses. Close parentheses. Ooh. Close parentheses. Let's tab them in one more time. Okay. And then whenever I do subqueries, I always start with the most easy. I just do select star and I just run it, make sure everything looks good. And again, once you get more practice, you're not going to need to do all of this, but when you're first learning, it's really good to just make sure that you're being a little redundant. Great, my data looks good. So let's go ahead and convert our start point and end point into distance. So we're going to do stdist, and we're going to do start, what did I call it? Start point. Start point. Start point, comma, end point. I like to do end then start, actually. As distance meters. And then I think it's stdistance. stdistance, okay? And then we'll do safe divide. And what are we dividing? We're dividing this little thing here by 1604 as distance miles. Okay. And the select star, just in case you haven't seen it in a minute, that just takes all of the columns from our subquery. Okay, so we have start point, end point, distance meters, distance miles, and everything looks good. Okay. All right, so now that we have our distance miles, we want to calculate our miles per hour. Okay, so I have this chunk, and basically what I'm going to do, I'm going to divide him by my time, my trip time here, trip time in hours. So let's not select all the columns anymore. Let's just take what we need. So we're going to get our generation bucket, trip time hours. Then we have our distance meter, distance mile. And then we're going to do safe divide. Safe divide what? Miles. This is miles. Hi, Miles. He's going right in here. And then we're going to do comma. What are we dividing him by? Trip time hours. So you can see how quickly this stuff can get really nasty. Okay, because look, we're doing the distance, then we're dividing it by 1604, then we're dividing it again by trip time in hours. And so sometimes you get like these chained types of manipulations, and it can just go on and on and on and on and on. If it gets too crazy, that's a point where you need to think about, how am I going to organize this? Maybe it's better to do it in more subqueries, even if it takes a little bit more processing time, because it's just hard for people to read that. But this is what we have. Okay, so now we're going to run it again. Okay, so now that our query's pulled back, let's go ahead and do some spot checking here. Okay, so we want to verify that what we did actually worked out correctly. So we're just going to do our miles and divide it by hours and see if it matches this number here. So we're going to do 0.0289 divided by 4.366. And you're going to say, oh, this isn't exactly right. Well, that's because I rounded these numbers because they're too crazy and I'm not going to type all that in my calculator. But I can see that it's 0.066 and that looks correct. So now that I've spot checked it and I feel good, now we have part 2 done and now we can flip over to part 3. Okay, so I'm just going to copy this. I'm going to paste it over here. This is my final work. And then the last part, and then let's go ahead and just delete part 2 and 1 because we've already done that. Okay. So the last thing we want to do is calculate the following group by generation type: number of riders, average trip duration, average distance, average miles per hour. Okay, so again, just like before, select from where? From this thing that we've just made. Okay. And then since we're doing aggregate, we know we're going to need a group by. So we're just going to put him there as a placeholder. Okay. So we want, by our generation bucket, we want the number of riders. That's just going to be a count star. And what does that mean? That just means by each generation bucket, give me how many rows are there. Because since we haven't done any aggregation, each row in this case is actually a ride. It's one individual ride. So this particular row was 4.36 hours. They went 46 meters, which comes out to just under a third of a mile. And then they went less than a mile per hour. Okay, so count star as total riders, average trip time hours as average trip duration, average distance miles as average distance, and then average miles per hour as average MPH. Okay, so now I have my aggregate functions, and since I have a group by and I have one column who is not being aggregated, he must be grouped by. So group by generation bucket. And then let's do order by generation bucket. And then we're going to hit Control Enter. So looking at this, we can see that millennials seem to be the biggest category. And looking at the average trip duration and the average distance, I'm not seeing anything too different. It does look like Gen X and Gen Z seem to go faster on their bikes. That could also be that their trip duration is shorter, but no, looks about the same. So it looks like they go a little bit faster on their bikes on average than, say, the silent generation or the boomers. So who knows? Maybe you could interpret that and say, oh, well, they're younger. Maybe they're able to pedal a little bit faster than, say, a boomer or someone who's in the silent generation. That's someone who's like 80. We also have a lot of people who are missing their birth year, and we can see that in terms of your trip duration, if you're missing your birth year, your trip time is really, really high. And what does that mean? That means that maybe if you are missing a birth year, you're not one of the members. They don't have your information, so you don't know what you're doing. Maybe you're a tourist and you're not like doing a typical work day, which is kind of what some of these look like, right? Okay, so that's it. So now that we've done this, we've given it a quick look, let's flip it over and do it in a CTE. So doing it in a CTE, we're going to start by just pulling out our part. We have part 1. Oh, and I forgot to label this. Part 2. Part 3. Okay, so let's just pull in part 1 copy. I'm going to open up a third window. This is going to be my CTE. We're going to call with part 1 as paste, collapse, comma, part 2 as. Now part 2 is just, this is all I need here. So this is all of the things that I'm going to be doing, right? But I need to just specify where is from. From where? From part 1. Okay? And if I were to do select star from part 2, you can see, okay, this is exactly where we were before with part 2. And then for part 3, we don't label it as a CTE. We leave that guy, he's exposed. Okay, so you have part 1, part 2, and then we'll do generation from part 2, and we're gonna group by 1, order by 1. Okay, so now that we have done this, we want to be thorough. We want to make sure that how we did it is the same thing, right? Because I told you that it would be, but that doesn't mean I'm always right. Sometimes I'm wrong. It does happen. Okay, so we're just going to look. This on this left side of the screen, this is the subquery. This on the right part of the screen, this is the CTE. And so we have boomer and we have 1, 2, 4, 6, 3, 5, 4. That's exactly the same here. Gen X, boop, 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 boop. And if I look at all these numbers, they're exactly the same. So I know I went really, really fast on the CTE, but the skinny of it is that you just take the part 1, you make that a CTE, then you do the select part here, you do all your manipulations, and you take that from, and then the CTE that you called part 1, and then so on. Let's jump back to the PowerPoint and wrap up this module. In today's module, we practiced our multiple CTEs and subqueries. We also pulled in a complex case statement to create generations, and then we used a group by to summarize our data. Thanks for joining. In our next module, we'll be going into some really major SQL topics, including unions and joins. See you there.